Welcome everyone. So in today's video, we are going to learn how we can use a short trick or a better method in order to find the solution of a quadratic. In traditionally, if we have a quadratic, so find the solution of a quadratic, we normally either use factorization method or middle term splitting method or quadratic formula. Here, we definitely have a better method in order to find the roots or solution of a quadratic, and this method is called the Po Shen Loh method. And in fact, possibly I don't know why this method is not taught in the school. So in order to find the solution of this quadratic using Po Shen Loh method, very first we have to find the sum and product of the roots. Like if we consider the roots of this quadratic equation as alpha and beta. So the sum of roots alpha plus beta will be 6. So call it as equation number 1, and product of roots, that is alpha multiplied beta, that will be minus 391, and this is equation number 2. So here we have sum of roots, that is 6. So if we find the average of sum of roots, so average of sum of roots will be 6 divided by 2, that means 3. So if the sum of roots, if the average of sum of roots is 3, so if we add and subtract a fixed quantity, that is t, from 3 and to 3, like this, so the sum of roots means 3 minus t plus 3 plus t will still be 6. And if we consider 3 minus t as alpha and 3 plus t as beta, so here the sum of roots is 6, and the value of, in fact, those roots are 3 minus t and 3 plus t. So here we have to find the value of t, and based on the value of t we will exactly find the exact roots of the quadratic. So here one condition is also there, that product of roots is minus 391. So if we multiply 3 minus t and 3 plus t, so it will be equal to minus 391. After simplifying the left hand side using identity, a minus b times a plus b is always written as a square minus b square. The left hand side of the resultant equation will be 9 minus t square, which is minus 391. Further, if we simplify it, we have t square is equal to 391 plus 9. So right hand side becomes 400. Again, means we have t square is equal to 400. So if we apply a square root on both sides of this equation, so the values of t will be 20 or minus 20. So when we have values of t, so the roots alpha, that will be 3 minus t, and root beta, that will be 3 plus t, will be 3 minus 20, in fact minus 17, and 3 plus 20, that will be 23. So the roots of the quadratic are minus 17 and 23. Further, if we use the value of t as minus 20, it won't affect the final value of the roots. In fact, if we use the value of minus 20, so 3 plus t will become minus 17, and 3 minus t will become plus 23. So it won't affect the final result of the quadratic if we use the value of t as 20 or minus 20. So here one question obviously arises, that why we are adding and subtracting from the average of the root. To understand the concept, let us consider about the graph of the quadratic. That will be a parabola opening upward if we consider the leading coefficient as positive, and this is x-axis. So if the real roots of the quadratic exist, that means the graph of the quadratic will cut to the real x-axis at 2 points. So here this is the axis of symmetry, and the graph will be exact same from left hand side and right hand side about this axis. So this is the midpoint of the roots. So if we call it as m, so the midpoint of roots of the quadratic alpha and beta is m. That means the alpha and beta are equidistant from M. That means this distance and this distance will obviously be equal. That means the roots are equidistant from the mean of roots. That's why we are adding and subtracting t from the mean of or the average of sum of roots. So that is the reason why we are adding t and subtracting t. So I hope this method will be quite helpful for you. So this is from my side for today.